And here an extension of the mean value theorem is Rolle's theorem, which states if f is continuous on the closed interval and differentiable on the open interval, and if f of a equals 0 and f of b equals 0, then there exists at least one point c in the interval such that f prime of c is 0. So here are two visuals on the right where f of a equals f of b, which equals 0. And here's a possible c value. So here is f prime of c equals 0 if there are two values where your y values equal 0. Now, keep in mind that Rolle's theorem is not only true when f of a equals f of b equals 0. There's another way you can visualize it. Let's say we have a function that looks something like this. Well, we see that this function will never equal 0, yet Rolle's theorem still applies. So let's say this is A, this is B. So going up to here and going up to here, we can see that f of a equals f of b, hopefully. The way I've drawn it, make sure yours works that way. So we see here that f of a equals f of b, yet it does not equal 0, right? But in this case, f of a equals f of b, which does equal 0. So there still exists some point c in that interval where f prime of c equals 0. So keep in mind that Rolle's theorem still works because here this line, f of b minus f of a over b minus a, is still going to equal 0. And these tangent lines and these secant lines are still parallel. So we see Rolle's theorem in this textbook focuses on f of a equaling f of b equaling 0, but Rolle's theorem overall works as long as f of a equals f of b. It does not have to equal 0, but in this textbook it does focus on that, so keep in mind. So let's get into some practice problems.